Today's topic is guide wavelength, group velocity, and phase velocity, and what is the relation between the guide wavelength, group velocity, and phase velocity. So, in the previous session, I have told what is a transmission line and why we are needing the transmission line and why we are using the waveguides, and when we are having the microwave frequency ranges we are having the transmission, and at the transmission we have to know some of the definitions, important definitions. Okay, so in the previous session I have told that, and not only with that, I have said about the equivalent circuit of our transmission line. So like this I have told what is the transmission line means. It is in our electronics, to carry the RF signal we need an guided media with minimum power loss. So for that we need a guided media called as transmission line. So that means in order to carry the RF signals from one point to another point with minimum loss of power is going to be done with this transmission line. So when we are having the minimum loss of power loss, that can be depends upon the physical characteristics and electrical characteristics of transmission line. So in that, physical means that is the size, length, height. So these are some of the examples of physical characteristics. And what are the electrical characteristics means, that is resistance, conductance, inductance. Okay, so like this we are considered across the electrical parameters. So like this we are using the transmission lines, and when we are having the traditional transmission lines, these are not used at high microwave frequency ranges. Okay, so for that we need a special type to use, and what is that is calling as waveguide. So that means the waveguide which will carrying some signals from one point to another point during the transmission with minimum power loss. Okay, so that is a waveguide. Why? Because this subject is dealing with the microwave communication. That means the communication is going to be done at microwave frequency ranges. So that's why we are going to be using a waveguide as a transmission line. Okay, so under that we are having so much of transmission lines. And first of all, the types is nothing but an parallel wire type, and twisted pair, coaxial cable, fiber optics, and the last one is waveguide. These are all comes under the classification of transmission lines. Okay, so at the microwave frequency ranges we are going to be using with the waveguides. Okay, and when we are having the equivalent circuit of a transmission line, in that we are having the resistance, capacitance, inductance, and also conductance. Okay, so in the previous session I have told that, and I have seen with the equations also of the equivalent circuit of a transmission line. And after that I have said what is a group velocity, what is a phase velocity. Generally in our transmission line they can say like that, but in this session I have dealing with the what is a guide wavelength, that is lambda g, and what is the relation between the guide wavelength, space wavelength, and cutoff wavelength, and what is a phase velocity, what is a group velocity, and what is the relation between the Vg and Cg. Okay, so like this we are having number of concepts in this session. So first of all, what is a guide wavelength? Okay, so the distance traveled by the wave in order to undergo a phase shift of 2 pi radians is called guide wavelength. The distance traveled by the wave in order to undergo a phase shift of 2 phase radians is called guide wavelength. Okay, the distance traveled by the wave in order to undergo a phase shift of 2 pi radians is known as guide wavelength, and that can be given as 2 pi by beta. Okay, so that is the guide wavelength, where lambda g is going to be calling as guide wavelength and beta is going to be calling as phase constant. So that is the relation between the phase constant and guide wavelength. That means it is inversely proportional to guide wavelength. Okay, so like this can be given as this. And what is the relation between guide wavelength, free space wavelength and cutoff wavelength? Okay, that means the relation between the lambda g, lambda and lambda c, that can be given as 1 by lambda square g equals to 1 by lambda square minus 1 by lambda c square. Okay, so where lambda g is the guide wavelength and lambda is the free space wavelength and lambda c is the cutoff wavelength. Okay, so next, so in order to have the derivation between these three concepts, we are going to be having some derivation. So solve of this. 1 by lambda g square equals to 1 by lambda square minus 1 by lambda c square. Okay, so from this we can write as this 1 by lambda square. So you can see this in this just a previous formula, and from this the first equation we are getting as this. Why? Because this equation is going to be taken as LCM. Okay, by taking as LCM, we are getting as lambda c square lambda square. Okay, so next 1 by lambda g square equals to, when we are having the lambda square in this, when it is not there, this one, that can be taken as. So in this equation there is a small mistake, that in this you can write this as lambda c square minus lambda square. Okay, so instead of lambda square we can write as lambda c. Okay, so like this. So by this we are getting as this, and after that we are division with lambda c square. Both the numerator and denominator can be division with lambda c square. Okay, so at the RHS side, so when we are having this term, so when we are having this term, we are getting as lambda c by lambda c square in this same. Okay, and by this also lambda square by lambda c square. Okay, so this will be cancelled as 1, that is 1 minus lambda by lambda c square, as this is going to be written. And in this, the numerator, you can see this, the lambda c square and the lambda c square cancels, it only remains the lambda square. So from this equation we are getting as this, that is 1 minus lambda by lambda whole square by lambda square. Okay, so this can be written as this. Why? Because it is in terms of 1 by. Okay, this term is in terms of 1 by lambda g square. So we have to get the original not with the 1 by. Okay, so that is lambda g square equals to lambda square by 1 minus lambda by whole square. Why? Because whenever we are having in the 1 by is going to be reverse of this. Why? Because if we are taking as lambda g square, the numerator will become as denominator becomes numerator. So like that we can get as lambda g square equals to lambda square by 1 minus lambda by lambda c whole square. So from this overall equation, lambda g square equals to lambda square by 1 minus lambda by lambda c whole to the power of square. And overall we can write as, why? Because we are not having the square, so we can have a square root of this. Why? Because at the LHS, if we are having the square, at the RH, if we apply to the RHS, we can get as, okay, so we can get as this one, that is lambda g equals to, the square is going to be having as square root of. Okay, so when we are having the square root of this term, whenever we are having this term will be coming as 1. Why? Because if we are taking as square root, when the square root is going to be given as square root of lambda square, the square and square root is going to be cancelled and remaining only with the lambda. So whenever we are taking as a lambda, that is nothing but a free space wavelength, and which will be equals to the 1. So like that we can taking as directly as 1. Okay, so 1 by under root of 1 minus lambda by lambda c whole square. Okay, so therefore the guide wavelength can be given as lambda g equals to 1 by under root of 1 minus lambda by lambda c whole to the power of square. Okay, so like this we can give the equation for our guide wavelength. So what is an phase velocity? So the velocity in which a wave changes its phase in a direction parallel to walls of the waveguide. So in the previous session I have said about the phase velocity, but whenever we are having in the waveguide, what is the equation? Okay, so in order to see that phase velocity of a waveguide, this is the equation. Okay, that means the velocity with which a wave change its phase in a direction parallel to walls of the waveguide is going to be calling as phase velocity, and that can be given as Vp, that is phase velocity, equals to f into lambda g. F is the frequency and lambda g is the guide wavelength. Okay, and that can be given as f into lambda by 1 minus lambda by lambda c whole to the power of square. Why? Because the lambda g is equals to the lambda by under root of 1 minus lambda by lambda c whole square is the formula for lambda g. So we have substituted the value of that lambda g in Vp formula. Okay, so finally the Vp equals to Vc by under root of 1 minus lambda by lambda c whole square. Okay, so what is a Vp means? That is a phase velocity, and what is a Vc means? Velocity of light. Okay, so velocity of light can be given as we are having the lambda in terms of Cf. Okay, so like that we are taking as Vc. Okay, so that is lambda c equals to cutoff wavelength, and lambda is the free space wavelength, and lambda g is the guide wavelength, and f is the frequency of the wave. Okay, so frequency of the signal or wave, both are same. So this is the formula for phase velocity. And what is a group velocity? Group velocity is the velocity of group of waves in the direction which is parallel to our conducting surface is called as group velocity. Okay, you can see this how we are going to be taking as group velocity means here it is having a propagating surface, that is the main base of our waveguide, and it is having some angles of reflections, and in that how we are taking means it is the direction of propagation is going to be seen in this figure, and that is the Vg, okay, which is perpendicular to our original direction of propagation, and it is very parallel to our conducting surface, that is taken as Vg, and Vn is the original velocity of our signal. Okay, so like this the product of group and phase velocity is the square of velocity of light. Okay, that means we can giving as Vg into Vp equals to Vc square, or under root of Vg into Vp equals to Vc. Okay, so where Vg equals to group velocity and Vp equals to phase velocity and Vc equals to velocity of light. So when we are having the equation, that is Vg equals to Vc square by Vp equals to, where Vp is having some formula, and that is going to be substituted as, that is Vc by 1 minus lambda by lambda c whole square. This the formula is going to be substituted in terms of Vp. Okay, so where Vg equals to Vc square under root of 1 minus lambda by lambda c whole square by Vc. So where the denominator, that is Vc, is going to be cancelled. Why? Because it is having the Vc square, and 1 Vc is going to be cancelled, and we are getting as Vc into 1 minus lambda by lambda c whole square, that is in terms of square root. Okay, so that is Vg equals to Vc under root of 1 minus lambda by lambda c whole square. This is the relation between the Vg and Vc. So when we are having the waveguides, that is we are having different types of waveguides. Under that we are having rectangular, circular and elliptical. So basically in our transmission we are going to be using the rectangular waveguide and circular waveguide. So we are well known about the dominant modes, that is we are having some transverse electric mode or transverse magnetic mode or transverse electrical and magnetic modes. Okay, TEM mode, that is going to be calling as. So like that, in our rectangular waveguide, what is the dominant mode means, that is TE10, that is we are going to be calling as TE10 or TE01. Both are same in our rectangular waveguide. So in the rectangular waveguide, the dominant mode is TE10, and in the circular waveguide, that is TE11. Okay, double one. Okay, this is the dominant mode under the rectangular waveguide and circular waveguide. So what is the cutoff wavelength under the rectangular waveguide means lambda c equals to 2a under the rectangular waveguide, and when we are having the cutoff frequency, that is Fc equals to c by 2a is the frequency of the rectangular waveguide. And what are the circular waveguide cutoff wavelength means, that is lambda c equals to 1.706 d, and wherever the cutoff frequency is Fc equals to c by 1 plus 706 d is the cutoff frequency. Okay, so when a wave deflected from a conducting wall has two velocity in a direction parallel to the wall, namely the group velocity and phase velocity, that is Vg into Vp equals to Vc square. Okay, so we are having two conditions, that is Vp is greater than the Vc and where Vg is lesser than the Vc. Okay, the history be noted. And I have said have covered with the guide wavelength and what is the relation between the guide wavelength and what is the space wavelength and what is the cutoff wavelength. Okay, what is the group velocity, what is the phase velocity, and I have said about the relation between the Vc and Vg also. Okay, so this is about our this topic. We have a quiz. So the first question is, in a waveguide, which of the following condition is true? In a waveguide, which of the following condition is true? The first one is phase velocity equals to c, and the second one is group velocity equals to c, and the third one is phase velocity is going to be greater than c. The last option is phase velocity is less than the c. So please note this question. So in a waveguide, which of the following condition is true? So these are having the options. The A option is the phase velocity equals to c. The second option is group velocity equals to c, and the third option is phase velocity is greater than c, and the last option is phase velocity is going to be lesser than the c. So what is an correct answer? The answer is C. That means the phase velocity is going to be greater than the c. The phase velocity is always greater than the speed of light in a waveguides. That means the group velocity is going to be very smaller than that of the speed of the light. Okay, so this is an correct answer. That means in a waveguide, which of the following condition is true means, that is the phase velocity is going to be very greater than the c. Okay, so that means the phase velocity is always greater than the speed of light in our waveguides. So this is an correct answer. Next question. The phase velocity refers to a group of waves and the group velocity refers to a single wave, whether it is a true statement or a false statement. That means the phase velocity refers to a group of waves, the group velocity refers to a single wave. So whether it is a true statement or false, that option is the A1 is true and the B1 is false. Which one is the correct answer? Please note this question. The phase velocity refers to a group of waves and the group velocity refers to a single wave, whether it is a true statement or a false statement. Please give an answer. That is false. Why? Because I have said that the group velocity refers to a group of waves, not a single wave. The phase velocity is going to be refers to the velocity of a single wave in our waveguides. So that's why the group velocity is not a single wave and the phase velocity is not a group of waves. Okay, so that's why it is a false statement. The phase velocity refers to a single wave and the group velocity refers to a group of waves. So that's why it is a false statement. Okay, the next question. The phase and group velocities does not depends on which of the following. The phase and group velocities does not depends on which of the following. The option A is frequency, option B is wavelength, option C is phase constant and option D is attenuation constant. That means the phase and group velocities does not depends on which of the following, that is frequency, wavelength, phase constant and attenuation constant. So which one is the correct answer? Please note this question. The phase and group velocities does not depend on which of the following parameter. That means which will not be depends on the following parameters. The option A is frequency, and the option B is wavelength, and the option C is phase constant, and the option D is attenuation constant. So which one is the correct answer? That is D, attenuation constant. That means the phase and group velocities are directly related to by the frequency, wavelength and phase constant. It is independent of the attenuation constant. You can see with the formula also, whenever we are having the phase and group velocities equation, in that it is not having any attenuation constant, which will depend only on frequency and wavelength and phase constant. Other than that is nothing but an attenuation constant. Okay, you can see in the formula of the previous slide, you can have a formula between the phase and group velocities relation. So under that we don't have the attenuation constant, we only having the relation between the frequency, wavelength and phase constant. That's why the D option is the correct answer, that is attenuation constant is the correct answer. So the next question, the distance between two successive points in a waveguide is the distance between two successive points in a waveguide is the option A is guided wavelength, option B is 2 into guided wavelength, and option C is guided wavelength by 2, and option D is guided wavelength by 4. So which one is the correct answer? That is the distance between the two successive points in a waveguide is the either guided wavelength or 2 into guided wavelength or guided wavelength by 2 or guided wavelength by 4. So which one is the correct answer? Please note this question. The distance between two successive points in a waveguide is the option A is guided wavelength, and the option B is 2 into guided wavelength, and the option C is guided wavelength by 2, and the option D is guided wavelength by 4. So which one is the correct answer? That is option C. That means the distance between the two successive points in a waveguide, that is equals to the half of the guided wavelength. Okay, that means the distance between the two successive points in a waveguide, which will be equals to the half of the guided wavelength. That means the option C is the correct answer, that is guided wavelength by 2. Okay, the distance between the two successive points in a waveguide is going to be depends, that is equals to the guided wavelength by 2 is the correct answer, that is half of the guided wavelength. So this is a correct answer. So in this session I have said what is the group velocity, what is the phase velocity, and what is the relation, and what is the guided wavelength. Okay, and what is the relation between the guided wavelength and space wavelength and cutoff wavelength. Okay, so this is the relation. So let us have a revision of this. So guided wavelength is nothing but an so guided wavelength is going to be given as lambda g, that is denoted as the distance travelled by the wave in order to undergo a phase shift of 2 pi radians is called as guide wavelength, that is lambda g, and that can be given as the lambda g equals to 2 pi by beta, where lambda g is the guide wavelength and beta is the phase constant and 2 pi is the phase shift of our single signal frequency. Okay, so that is the guide wavelength, and we have a relation between the guide wavelength, free space wavelength, and the cutoff wavelength. So how it can be given as nothing but 1 by lambda square g equals to 1 by lambda square minus 1 by lambda c square, where the lambda g is the guide wavelength and the lambda is the free space wavelength and the lambda c is the cutoff wavelength. And in order to have a relation between the lambda g and lambda c and lambda, we are knowing of this equation. That is, whenever we are having the equation, that equation is going to be taken as LCM at the right hand side, and we are getting as lambda c square minus lambda square by lambda c square into lambda square. Okay, so that is taken as the numerator and denominator can be division with lambda c square. So whenever we are division with lambda c square, the first term, that is lambda c square by lambda c square, that will be cancelled and it is going to be getting as 1, and that minus lambda square by lambda c square, it will remains as it is, and by lambda c square into lambda square by lambda c square, it is going to be cancelled and we are remaining only with the lambda square. And this equation can be given as this. Why? Because 1 by lambda g is going to be taken as 1 minus lambda by lambda c square whole square by lambda square, but it is in terms of 1 by. Okay, so when we are taking as a single term, that is lambda g square, and that can be given as, that means the numerator is going to be becoming as denominator is going to be becoming as numerator. So like that we are getting as lambda square by 1 minus lambda by lambda c whole square for the equation of lambda g square. So, and this can be given as lambda square by 1 minus lambda by lambda c whole square, and whenever we are taking a square, we can take as an square root at the, when it is going to be applying for the right hand side, that can be act as an square root, and this term we are having as lambda not with the 1, it is wrong in this equation, that it is nothing but an lambda. Okay, so lambda square to the square root of this is going to be the square root, and square is going to be cancelled, and we are going to be remaining only with the lambda. Instead of 1 in this equation, you have to write as an lambda. Okay, so lambda by under square root of 1 minus lambda by lambda c whole square. Okay, so this is an equation of the lambda g. That means this is the relation between the lambda g, lambda and lambda c. Okay, so this is the final equation. And what is the phase velocity? Means the velocity with which a wave can change its phase in a direction parallel to the walls of the waveguide is called as phase velocity, and that can be given as Vp equals to Vc by under root of 1 minus lambda by lambda c whole square. Okay, so we have well known about the what is Vp, what is Vc, what is the lambda c, and what is the lambda, and what is the lambda g. Okay, so like this we can learn of this phase velocity. And the next one is group velocity. The group velocity is the velocity of the group of waves in the direction parallel to the conducting surface. The group velocity is the velocity of the group of waves in a direction parallel to the conducting surface. You can see within this figure, you can have a clear cut of our group velocity, and that group velocity can be given as the product of Vg into Vp. What is Vg means? It is group velocity. Vp means that is phase velocity, and that is equals to Vc square. And we can also take in as Vc equals to square root of Vg into Vp also. Okay, so where Vg is going to be group velocity, Vp is the phase velocity, and Vc is the velocity of light. And overall we can give the equation that Vg equals to Vc under root of 1 minus lambda by lambda c whole square is the equation between the Vg and Vc. And when we are having the waveguides, we are having different types of waveguides. Under that we are having rectangular and circular waveguide. So when we are having the rectangular waveguide, we are having the dominant mode, that is nothing but an TE10 is the dominant mode under the rectangular waveguide, and it is also having the cutoff wavelength, that is lambda c equals to 2a, and where cutoff frequency is the fc equals to c by 2a under the rectangular waveguide, and at the circular waveguide, that is dominant mode is TE11 and the cutoff wavelength is lambda c equals to 1.706d, and cutoff frequency is the fc equals to c by 1.706d. Okay, so that is an when we are having the consideration of the waveguide, when it is having some rectangular, it is having different wavelength, and when it is having circular, it is having different wavelength. Why? Because the construction of the waveguide is going to be different under the rectangular and the circular waveguide. Okay, so I have said that what is a waveguide means. It is nothing but a transmission line which is used to carry the energy which is in the form of microwave frequency ranges from one point to another point with little amount of the power loss. Okay, so that is the use of waveguide. Okay, so this is our summary about the guide wavelength and relation between the guide wavelength, space wavelength and cutoff wavelength, and what is the phase velocity and what is the group velocity and what is the relation between the VG and VC, and we have done some of the quiz also in this session. Okay, so thank you.